At 26,000 students plus faculty, the energy requirement for Ohio University is quite large. In 2016, it was estimated that Ohio University consumed around 105 million kilowatt hours of electricity at 6 cents per. This puts Ohio University's yearly energy costs in 2016 to be around $6 million.
Process engineering. A combined natural gas-fired power plant produces electricity via the Rankine cycle. Natural gas is supplied to the plant, mixed with air, and then combusted in a controlled setting. The hot gases exchange heat with liquid water and produce steam. The steam generated can then run through a steam turbine and generate electricity. The process flow diagram shows the natural gas supply and turbine as well as the water source, heat stack, and steam turbine. Ohio University's campus would currently require 130,000 megawatt hours of electricity. With 8,760 hours per year, the proposed power plant would be required to generate 15 megawatts. To be ample size, the proposed power plant would consist of 4 5-megawatt turbines. Assuming the plant would run 24 hours a day, 7 days a week, the plant would consume 50,079,168 pounds of natural gas a year.
The process economics shows us what the annual cost of natural gas will be for the university. The university requires 50,079,168 pounds of natural gas at a cost of 5.37 cents per pound. This equates to a total cost being $2.69 million a year. The bus bar cost is calculated with the values shown here on this slide and the rest being industry standards. After calculation, the bus bar cost is 9.9 cents per kilowatt hour.
If the economics of a project prove to be feasible, it is time to move on to risk analysis. Risk analysis is used to identify and evaluate any particular risk involved with a project. Organization, politics, and technical uncertainties can jeopardize the profitability of any project. A natural gas power plant will have specific uncertainties that vary from other power generation projects. Upstream, midstream, downstream, and output are terms used to describe processes specific to natural gas. Impact, visibility, and return on equity are terms used to quantitatively and qualitatively assess risks. Risks are typically plotted on a chart, with return on equity being the y-axis and debt leverage being the x-axis. This specific chart was created for a natural gas project and contains many risks. 4 of the more extreme risks are located on the right and shown on the graph with stars.
Once this natural gas power plant is finished, keeping it safe and efficient in that order will be the focus of management. To ensure both of these qualities, a team of skilled engineers and technicians must be employed. These positions would include at minimum a plant manager, floor managers, control engineers, maintenance engineers, and technicians. The plant manager would be in charge of the big decision-making processes and evaluating safe and efficient behavior. Floor managers would then be responsible for the day-to-day activity and enforcing the rules that keep the workers safe and the plant efficient. And there must always be at least one floor manager present in the plant, just in order to ensure safety. A team of control engineers would then be directly responsible for overseeing the power output and effective loads being experienced throughout the power plant. Maintenance engineers need to be able to oversee and confirm that the power plant is working safely and efficiently. And if the equipment is not operating safely, they must also design a solution for the problem. Technicians would then be the employees that are responsible for the actual manning of the non-critical stations, reporting of subpar equipment, and repairing said equipment if a specialist is not required.
Natural gas is becoming a very popular resource to use to produce power. Fracking seems to be the method a lot of people are choosing to do, but this has some issues with emissions as any method to harvest natural gas would. Our plant uses air scrubbing technologies to help prevent poor emissions into our environment. Using the program GREET allows us to input our type of fuel and also pick what we want our product to be. After this, a pathway is constructed, and with that, different types of emissions are produced, and you can see how much is actually produced with the path we have chosen. As you can see from the example below, it breaks down each emission and shows us how much is produced. This is a great tool to give a good idea of what emissions you are looking at. There are policies and subsidies out there that allow power plants to operate and build for less or even receive benefits depending on what fuel they use. Ohio wants power generated by renewable resources, so they implemented a policy that requires this. An example of a subsidy for natural gas is in Texas, a natural gas power plant was subsidized for 25 cents a megawatt hour. This is a prime example of a company wanting to produce a large power plant to produce a lot of power, and this is something that might attract them to certain areas. Policies are different state to state depending on what the fuel you want to use and how much power you would like to produce. These policies are there to encourage and regulate the production of power plants across the nation.
The power requirements of the Ohio University can be met by a gas-fired power plant. Overall, a natural gas power plant is a viable option to power Ohio University, but will pose economic and environmental challenges.